Hello everyone. In this video, we will cover the 2-year term insurance. Again, the discrete case. In this video, the discrete case means the death benefit is payable at the end of the year of death. Now consider a 2-year term insurance issued to an individual at age X, death benefit 1 payable at the end of the year of death. If the individual dies before reaching age X plus 1, that is Kx equals 0, the insurer pays 1 and the present value is nil. Or else, if the individual dies between ages X plus 1 and X plus 2, that is Kx equals 1, the insurer will pay 1 at this time point and the present value is nil squared. Or else, if the individual survives beyond this 2-year period, then the insurer pays nothing. The present value, again, a random variable. Kx equals 0, the present value is nil. Kx equals 1, nil square. Kx greater than or equals to 0. The corresponding probability, Qx, 1 bar Qx, and 2px. The expected value of z, this is the notation. Nothing is changed as for the 1-year term insurance except for the number here. Now we have angle 2. Corresponds to, okay, this big A, insurance, benefit payable at the end of the year of death, issued to an individual at age X, this angle 2, a 2-year term insurance. 1 above the X, the benefit is only payable if the individual dies within this 2-year period. By definition, the expected value of z is nu times qx plus nu square times 1 bar qx. The expected value of z square, we have this expression. And you can see that from the expected value of z, we have nu. The expected value of z square, we have nu square. So in terms of delta, nu square is evaluated at a double force of interest. So nu here is for delta, then nu square is 2 delta. Similarly, for the second term, nu square and nu square square. This expression is simply converting the original delta to 2 delta. We get this expression. And therefore, in terms of the actuarial notation, we can put a pre-superscript 2 along with this notation. This is the present value, the expected present value of a 2-year term insurance evaluated at a double force of interest. And then we have the variance. All right, so let's take a look at an example. Given that Q55 is 0.01, Q56 is 0.02, the interest rate I is 0.1. Find the variance of the present value random variable of a 2-year term insurance issued to an individual at age 55. The death benefit of the face amount is $800. The benefits are payable at the end of the year of death. The present value, if the individual dies before reaching age 56, that is K55 equals 0. This is the present value. If the individual dies between ages 56 and 57, that is K55 equals 1. The present value is 800 nu square. or else this is 0 if the individual survive beyond age 57. Nu is 1 over 1.1, and therefore we get the numbers here. The probability Q55 is 0.01. The second case, the probability that K55 equals 1, that is 1 bar Q55. This is P55 times Q56. The probability is 0.0198. And Z is 0 if K55 is greater than or equals to 2P55. We get 0.9702. With this PMF, we can get the expected value of Z and the variance of Z accordingly. The expected value of Z, 20.36. The expected value of Z squared, 13,944. And from that, we can get the variance. The notation, the expected value of Z, 800, and then this A notation, A55, angle 2, and then with the 1 above the 55. And then the expected value of Z squared. Another example, 2-year term insurance, death benefit 500, issued to an individual at age 62. The death benefit is payable at the end of the year of death. We have the 2-year select and ultimate table. I is 0.04. Calculate the APV of this insurance. The notation. This is a select life at age 62. We have the bracket 62 here. Angle 2, 2-year term insurance. All right, so from this expression, we need to get Q62, the select life. By definition, we have this expression, the corresponding number, L62, select life, and then L62 plus 1. We get 0.038311. And then 1 bar Q62, the select life at age 62. We have this expression. Upon calculation, we get this probability. Plug all the numbers into the expression, and then we can get the APV, 10.4176. Another example, a 2-year term insurance, death benefit 100, individual at age 45. Death benefit is payable at the end of the year of death. Mortality follows the Morpheus law with omega equals 110. Interest rate, I is 0.05 in the first year and 0.08 in the second year. Let Z to be the present value random variable for this insurance, and we are asked to calculate the variance of Z. All right, a time diagram. An individual at age 45. If the individual dies before reaching age 46, the insurer pays $100 at this time point. The present value, 100 times new. And in this first year, I is 0.05, so new is 1 over 1.05. If the individual dies between ages 46 and 47, the insurer pays 100 at this time point. The present value. In the second year, I is 0.08. And then in the first year, I is 0.05. The corresponding present value, 100 times 1 over 1.08 times 1 over 1.05. If the individual survives beyond age 47, the insurer pays nothing. All right, so this is the corresponding time diagram. All right, to get the expected value of Z or the expected value of Z squared, here I don't use the standard actuarial notation because for the standard actuarial notation, we assume that the interest rate is a constant. Okay, but now we have a varying interest rate, 0.05 in the first year and 0.08 in the second year. Therefore, I simply use the expected value of Z and the expected value of Z squared in the solution. We need to get the probability. Okay, mortality follows the Morpheus law. TQX equals T over omega minus X, and omega is equals to 110. The probability that K45 equals 0, which is Q45, we get 1 over 65. And then the probability that K45 equals 1 bar Q45, which is P45 times Q46, which is again 1 over 65. This is due to the De Morpheus law mortality model. All right, so we have the PMF of Z. The expected value of Z, we have this expression. Upon calculation, we get 2.821869. The expected value of Z squared, 259. From that, we can get the variance. And the answer is 251.215677. That's it for today's video. Thank you for watching. In the next video, we will generalize the end year term insurance. See you in the next video.